ਅੱਜ ਦੇ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਹਾਡਾ ਸਵਾਗਤ ਹੈ। ਅੱਜ ਦੀ ਕਲਾਸ ਵਿੱਚ ਅਸੀਂ ਕੈਮੀਕਲ ਪ੍ਰੋਪਰਟੀਜ਼ ਆਫ ਐਲਡੀਹਾਈਡਸ ਐਂਡ ਕੀਟੋਨਸ ਬਾਰੇ ਪੜਾਂਗੇ। The aldehydes and ketones undergo nucleophilic addition reactions, oxidation reactions and reduction reactions. ਬੱਚਿਓ, ਸਭ ਤੋਂ ਪਹਿਲਾਂ nucleophilic addition reactions ਨਾਲ ਸ਼ੁਰੂ ਕਰੀਏ। In this type of reaction, nucleophile reacts with carbonyl carbon atom of aldehydes and ketones. Aldehydes and ketones form addition products with reagents like hydrogen cyanide, sodium bisulphite and Grignard reagents.
We will first learn about addition of hydrogen cyanide, that is HCN. With hydrogen cyanide, carbonyl compounds form cyanohydrins, preferably in basic medium, in order to generate cyanide anion, that is Cn negative, for the nucleophile attack. The first example shown on the screen shows that acetaldehyde reacts with hydrogen cyanide to form acetaldehyde cyanohydrin. Acetone reacts with hydrogen cyanide to form acetone cyanohydrin. Cyanohydrins are useful synthetic reagents and can be used for the synthesis of alpha hydroxy acids and alpha amino acids by Strecker synthesis. Have a look at the equations on the screen. Acetaldehyde cyanohydrin reacts with water in acidic medium to form alpha hydroxy propionic acid or lactic acid. Acetaldehyde cyanohydrin reacts with ammonia. One molecule of water is lost to form an addition product which further undergoes hydrolysis in acidic medium to form alpha amino propionic acid, which is also called as alanine. Benzaldehyde cyanohydrin hydrolyzed in the presence of aqueous acid gives mandelic acid. We will now learn about addition of sodium bisulphite. Aldehydes and methyl ketones react with a saturated solution of sodium bisulphite to form white crystalline sodium bisulphite addition compound. The reaction is of reversible nature, but by using a saturated solution of sodium bisulphite, the equilibrium gets shifted to the right. Let us have a look at the equations on the screen. Acetaldehyde reacts with sodium bisulphite to form acetaldehyde sodium bisulphite. Acetone reacts with sodium bisulphite to form acetone sodium bisulphite. Let us now learn about addition of Grignard reagents, that is RMgX. These readily combine with carbonyl compounds to form addition products which are decomposed by water in the acidic medium to form alcohols. Acetaldehyde reacts with methyl magnesium iodide to form an addition product which on reaction with water in the presence of an acid forms isopropyl alcohol. Let us next learn about how ketones form tertiary alcohols. Acetone reacts with methyl magnesium iodide to form an addition product which on hydrolysis in the presence of an acid forms tertiary butyl alcohol. We will now learn about reactions with ammonia and ammonia derivatives. Aldehydes and ketones react with ammonia and primary amine to form imines. Imines are also known by an older name, Schiff's bases. Imine formation is acid catalyzed. A pH of 4.5 is an optimum condition. A pH in this range protonates the carbonyl oxygen atoms, forming a carbocation that is more susceptible to nucleophilic attack by the ammonia or amine than is the unprotonated carbonyl group. A lower pH would protonate the ammonia or amine to a greater extent, reducing its nucleophilicity. Acetaldehyde reacts with ammonia in the presence of ether to form acetaldehyde ammonia, which is an addition product. It breaks upon heating to form acetaldimine. Aldehydes react with primary amines in the presence of small amount of acid to form azomethanes or Schiff's bases. Benzaldehyde reacts with aniline in the presence of small amount of acid to form benzaaniline. Certain ammonia derivatives, hydroxylamine, hydrazine, phenylhydrazine, and semicarbazide react with carbonyl compounds in weakly acidic medium to form addition products which eliminate water molecule under the reaction conditions to form different products. Thus, the net reaction involves the substitution of oxygen atom of the carbonyl group, with groups G listed on the screen. Children, let us now discuss reaction with hydroxylamine, that is NH2OH. Oximes are formed as a product. Acetaldehyde reacts with hydroxylamine in acidic medium to form acetaldoxime and water. Acetone reacts with hydroxylamine in presence of acidic medium to form acetoxime and water.
Let us now learn about the reaction with hydrazine, that is NH2NH2. Aldehydes and ketones react with hydrazine in acidic medium to form hydrazones. Acetaldehyde reacts with hydrazine in acidic medium to form hydrazone of acetaldehyde. You can also see on the screen that acetone reacts with hydrazine in presence of acidic medium to form hydrazone of acetone. Children, let us now learn about reaction with phenylhydrazine, that is C6H5NHNH2. Aldehydes and ketones react with phenylhydrazine in acidic medium to form phenylhydrazones. Acetaldehyde reacts with phenylhydrazine in presence of acidic medium to form phenylhydrazone of acetaldehyde and water. Acetone reacts with phenylhydrazine in presence of acidic medium to form phenylhydrazone of acetone and water. We will next learn about reaction of semicarbazide with acetaldehyde in presence of hydrogen ions to form semicarbazone of acetaldehyde and water. Acetone reacts with semicarbazide in acidic medium to form semicarbazone of acetone and water.
We will now learn about the next reaction, which is formation of acetals and ketones by the addition of alcohols to aldehydes and ketones. Aldehydes react with alcohols on passing dry hydrochloric acid gas to form gem-dialkoxy compounds called acetals. Acetaldehyde reacts with ethyl alcohol on passing dry hydrochloric acid gas, forms hemiacetal. This, being unstable, takes up the second molecule of ethyl alcohol in dry hydrochloric acid, forms acetal. As the reaction is of reversible nature, the acetal can be converted back into the acetaldehyde by decomposing with dilute acid. Cyclic acetals are also formed when an aldehyde reacts with ethylene glycol, which is a dihydric alcohol, in the presence of para-toluene sulfonic acid. Or we can say PTS in short. Let us have a look at the equation on the screen. Acetaldehyde react with ethylene glycol in the presence of PTS to form 2-methyl-1,3-dioxolane, which is a cyclic acetal. Ketones do not react with monohydric alcohols but form cyclic ketals with ethylene glycol, as you see on the screen. Acetone react with ethylene glycol in presence of PTS to form 2,2-dimethyl-1,3-dioxolane, which is again a cyclic ketal.
Now we will discuss oxidation reactions of aldehydes and ketones. Aldehydes can be easily oxidized to acids with the same number of carbon atoms. Ketones are difficult to be oxidized and form acids with less number of carbon atoms. Oxidation of aldehydes. Aldehydes can be easily oxidized to acids with the help of oxidizing agents such as acidified potassium permanganate or acidified potassium dichromate solution. Let us have a look at a few equations on the screen. Acetaldehyde reacts with acidified potassium permanganate to form acetic acid. Benzaldehyde reacts with acidified potassium permanganate to form benzoic acid. Since aldehydes can be easily oxidized, they act as reducing agents and reduce compounds containing metal ions like silver monopositive ion and copper dipositive ions under basic conditions. Let us discuss some of these reactions now. We will first learn about reduction of Tollens reagent. Tollens reagent is an ammoniacal solution of silver nitrate and is prepared by adding an aqueous solution of ammonium hydroxide to that of silver nitrate till the precipitate of silver hydroxide initially formed just redissolves. Upon heating an aldehyde with Tollens reagent, the latter is reduced to metallic silver, which gets deposited on the inner walls of the tube and shines like a mirror. The reaction is often called silver mirror test. Let us now have a look at the equations one by one. Silver nitrate reacts with ammonium hydroxide to form silver hydroxide and ammonium nitrate. Silver hydroxide reacts with ammonium hydroxide to form a soluble complex and water. Acetaldehyde reacts with Tollens reagent to form acetic acid along with silver ammonia and water. Let us now learn about reduction of Fehling solution. Do you know about its color? It is deep blue solution obtained by mixing Pheling A and Pheling B. Pheling A is formed of copper sulfate solution and Pheling B is formed of sodium hydroxide solution containing some Rochel's salt, which is sodium potassium tartrate in equal volumes. When an aldehyde is heated with Pheling solution, a red precipitate of cuprous oxide gets formed. The reaction proceeds as shown on the screen. Acetaldehyde reacts with cupric ions and hydroxyl ions to form acetate ions and cuprous oxide, which is of red precipitate along with water. Aromatic aldehydes do not reduce Pheling solution. Reduction of Benedict solution. When an aldehyde is heated with Benedict solution, which is a solution of copper sulfate, sodium citrate and sodium carbonate, a red precipitate of cuprous oxide is formed. Benedict solution is a citrate complex of cupric ions and provides the cupric ions which combine with aldehyde in the alkaline medium as shown on the screen. Acetaldehyde reacts with cupric ions and hydroxyl ions to form acetate ions, cuprous oxide and water.
We will now learn about oxidation with sodium hypohalite, that is haloform reaction. When a methyl ketone, that is CH3 single bond C, double bond O, single bond R, and even acetaldehyde is reacted with halogen in aqueous sodium hydroxide, the ketone gets oxidized to the sodium salt of acid with one carbon atom less than ketone, and at the same time haloform, that is CHX3, also gets formed. Let us now have a look at the equations one by one. Sodium hydroxide reacts with halogen to form sodium halide and sodium hypohalite and water. Methyl ketone reacts with sodium hypohalite to form sodium salt of acid, that is RCOONA, haloform and sodium hydroxide. When the reaction is carried with iodine, a yellow precipitate of iodoform is obtained. Sodium hydroxide reacts with iodine to form sodium iodide and sodium hypoiodide and water. Methyl ketone, that is RCOCH3, reacts with sodium hypoiodide NaIO to form sodium salt of acid, that is RCOONA, iodoform, which consists of yellow precipitate and sodium hydroxide. We will next learn about Baeyer-Villiger oxidation. Certain aliphatic ketones are oxidized to form esters when reacted with some peracids like permonosulfuric acid, that is H2SO5. It is also called Carros acid or perbenzoic acid, that is C6H5COOOH or peracetic acid. Propanol reacts with peracetic acid to form methyl ethanoate and acetic acid. Let us now learn about oxidation by selenium dioxide, that is SeO2. Carbonyl compounds containing a methylene group adjacent to a carbonyl group are oxidized by selenium dioxide to a dicarbonyl compound. For example, Propanone reacts with selenium dioxide to form methyl glyoxyl, selenium, and water. Butanone reacts with selenium dioxide to form dimethyl glyoxyl and selenium and water. Even some aldehydes, except formaldehyde, can also be oxidized with selenium dioxide. Ethanol is oxidized with selenium dioxide to form glyoxyl, selenium, and water.
Now we will discuss third type of reaction, that is reduction reactions of aldehydes and ketones. Aldehydes and ketones are reduced to alcohols by partial reduction or hydrocarbons by complete reduction with suitable reagents. We will now briefly discuss these reactions one by one. We will next discuss about reduction to alcohols or partial reduction. Aldehydes are reduced to primary alcohols while ketones form secondary alcohols as a result of partial reduction. A number of reagents can be used for this purpose. Catalytic hydrogenation of aldehydes and ketones is carried in the presence of nickel, platinum or palladium, or chemically by complex metal hydrides such as lithium aluminum hydride or LiAlH4 and sodium borohydride or NaBH4. For example, acetaldehyde gets partially reduced with hydrogen in the presence of nickel, platinum or palladium to ethyl alcohol. Acetone gets partially reduced with hydrogen in the presence of nickel, platinum or palladium to isopropyl alcohol.
Children, let us now learn about Meerwein Pondorof Verely reduction, that is MPV reduction. Ketones are reduced to secondary alcohols with isopropyl alcohol in the presence of aluminium isopropoxide as shown on the screen. Reduction to pinacols, that is bimolecular reduction. Ketones are reduced to pinacols, that is dihydric alcohols with magnesium amalgam and water. It is called bimolecular reduction since two molecules of ketones are involved. Have a look at the equation on the screen. Two molecules of acetone react with magnesium amalgam to give an addition product which upon hydrolysis gives 2,3-dimethyl-butane 2,3-diol. Reduction to hydrocarbons, that is complete reduction. Reduction with zinc amalgam and hydrochloric acid, that is Clemenson's reduction. Acetaldehyde reacts with zinc amalgam and hydrochloric acid to form ethane and water. Acetone reacts with zinc amalgam and hydrochloric acid to form propane and water. Reduction with hydrogen iodide in the presence of red phosphorus. The reaction is carried at about 420 Kelvin. Let us take an example. Acetaldehyde is reduced with hydrogen iodide in the presence of red phosphorus at 420 Kelvin to ethane. Acetone is reduced with hydrogen iodide in the presence of red phosphorus at 420 Kelvin temperature to propane. Reduction with hydrazine and potassium hydroxide, that is Wolff-Kishner reduction. The reduction is carried out in presence of high boiling point solvent such as ethylene glycol. For example, acetaldehyde reacts with hydrazine, forms hydrazone, and a water molecule is lost. Hydrazone formed is heated with potassium hydroxide to give ethane and nitrogen molecule. Reactions with bases. Aldehydes and ketones form a number of products in the presence of alkalis or bases. Aldol condensation involving alpha hydrogen. Aldehydes and ketones with at least one alpha hydrogen atom take part in aldol condensation in the presence of dilute alkali. For example, sodium hydroxide, sodium carbonate. As a result, two molecules condense to form a beta hydroxyaldehyde or beta hydroxyketone, which gets dehydrated on heating with dilute acid to form alpha beta unsaturated compound. For example, two molecules of acetaldehyde condense in basic medium to form acetaldol, that is, aldol, which in acidic medium, when heated, loses water molecules to form croton aldehyde. Acetone condense with another molecule of acetone in basic medium to form diacetonyl alcohol, that is, aldol, which on heating in presence of acid loses a water molecule to form mesitile oxide. Two molecules of acetophenone condense in basic medium to form aldol, which in acidic medium loses a water molecule to form 1,3-diphenyl 3-methyl prop 2-in-1-one.
Cannizzarose reaction. We have discussed that aldehydes or ketones with at least one alpha hydrogen take part in aldol condensation. However, the aldehydes which have no alpha hydrogen atom, when heated with caustic alkalis like sodium hydroxide or potassium hydroxide, undergo Cannizzarose reaction. In this reaction, two molecules of aldehydes undergo self-oxidation and reduction to form a mixture of alcohol and salt of carboxylic acid. For example, two molecules of formaldehyde undergo self-oxidation and reduction when heated with sodium hydroxide, forms methyl alcohol and sodium formate. The reaction can also take place between different aldehydes which do not have alpha hydrogen atom. This is called cross Cannizzarose reaction. For example, anisaldehyde reacts with formaldehyde in the presence of and sodium hydroxide to form para-methoxybenzyl alcohol and sodium formate.
Tishenko reaction. This is a modified form of Cannizzarose reaction in which all aldehydes participate, whether they have an alpha hydrogen atom or not. Two molecules of the acetaldehyde combine in the presence of aluminium ethoxide to form acetic acid and ethyl alcohol. This acetic acid and ethyl alcohol combine to give ethyl acetate. Perkins reaction. In this reaction, an aromatic aldehyde such as benzaldehyde is heated with an acetic anhydride. In the presence of base water molecule is lost, an intermediate condensation product is formed. which is boiled with water, cinnamic acid, and acetic acid is formed. Children, let us now learn about benzoin condensation. Two molecules of aromatic aldehyde, such as benzaldehyde, when heated in the presence of alcoholic potassium cyanide, condense to form benzoin, as shown in this figure. We will now learn about Claisen reaction. It is a reaction between aromatic aldehyde or ketone and aliphatic aldehyde or ketone in the presence of dilute alkali to form an alpha-beta unsaturated compound. The reaction is also called Claisen-Schmidt reaction. Reaction on the screen shows that benzaldehyde reacts with acetaldehyde in presence of sodium hydroxide to form cinnamic aldehyde.
At the end of topic, let me ask one question. Hydrazones of aldehydes and ketones are not prepared in strongly acidic medium. Why? And the answer is, hydrazones are formed by reacting carbonyl compounds with hydrazine, which acts as a nucleophile. In the strongly acidic medium, hydrazine gets protonated and therefore it is not in a position to act as a nucleophile. As a result, hydrazones of aldehydes and ketones are not prepared in strongly acidic medium. बच्चों, ਮੈਨੂੰ उम्मीद है कि ਅੱਜ ਦਾ ਇਹ ਪਾਠ ਤੁਹਾਨੂੰ ਕਾਫੀ ਇੰਟਰਸਟਿੰਗ ਲੱਗਿਆ ਹੋਵੇਗਾ। Thank you for your kind attention and see you next time.